So picture this. You've got a teenage oboe player.
Okay.
It's 1757. He's 19 years old, and he is standing in the middle of the smoke and the mud of this absolutely devastating military clash, the Battle of Hastenbeck.
Wow. Not exactly a concert hall.
No, not at all. He's terrified, he gets accused of desertion, and he basically flees his home in Germany. He crosses the sea to England as a refugee, just trying to scrape together a normal life playing music.
Right.
But here's the thing. If you were looking at this kid then, you would never ever guess that this exact same fleeing musician would eventually build a giant metal tube in his backyard
Yeah.
and literally overnight become the first human being since antiquity to double the known size of the solar
I
system.
mean, it really sounds like a piece of historical fiction, doesn't it?
It totally does.
But we are talking about a massive paradigm shift in human understanding here.
Mm-hmm.
And the craziest part is that it really all started with a musical instrument.
Welcome to the Deep Dive. Today, our mission is to explore the biographical profile of William Herschel. And we've got a really fantastic stack of historical sources to go through.
Yeah, we do.
And I want to say up front, this isn't just like a dry list of astronomical firsts.
No, definitely not.
This is a deeply human story. It's about relentless obsession, this incredible sibling partnership, and how a musician's quest for, perfect harmony completely revolutionized our understanding of the universe.
Yeah, to just set the scene for you really quickly, William Herschel was a German-British astronomer and composer from the 18th century.
Mm-hmm.
And if you look at the foundation of modern observational astronomy, so, how we survey the deep sky, how we understand gravity outside our solar system, even how we look at invisible light, he essentially laid the groundwork for all of it.
Which is wild.
Right. But he didn't start his career looking through an eyepiece. Like you said, he started in an orchestra pit.
So let's trace how that happens because it feels like such a massive leap.
It does.
He was born in Hanover in 1738. His father was an oboist in a military band, the Hanoverian Guards.
Right.
And William followed right in his footsteps. But after that brutal defeat at Hastenbeck, his father essentially tells him to run.
Just get out of there.
Exactly. So he gets to England, anglicizes his name from Friedrich Wilhelm to Frederick William, and just leans into his musical talent. I mean, he plays the oboe, the violin, the harpsichord.
He was incredibly gifted.
He was. He ends up in Bath, which was a very fashionable spa town at the time. He becomes the director of public concerts. He's a highly successful organist. The guy even composes 24 symphonies.
Yeah.
So I am looking at these notes, and I'm just wondering, how does a guy who is comfortably writing symphonies for the elite just pivot to deep space optics?
Well, see, it wasn't really a pivot. Not exactly. It was more of an extension of how his brain already worked.
Oh, really?
Yeah. So in the 18th century, there was this whole concept of the philosophical gentleman.
Okay, what does that mean?
It basically meant someone upwardly mobile who was intellectually engaged in, like, wide-ranging practical and logical pursuits. Science, philosophy, all of it.
Got it.
And Herschel wanted into that world. The sources show that in the 1770s, he started reading books on natural philosophy. And one book in particular was called Harmonics, or the Philosophy of Musical Sounds.
Okay, but how does a book on musical sounds lead to staring at stars?
Because music is fundamentally mathematics.
Oh, right.
Like think about a harpsichord or a violin. When you pluck a string, it vibrates at a specific frequency to create a pitch.
Okay.
But if you press down on the exact middle of that string, have its length, you get an octave. It is a perfect mathematical ratio. Herschel completely internalized this. He realized that the universe operates on these strict logical proportions. So that book on harmonics actually led him straight to texts on optics.
Because light is also waves.
Exactly. He saw that light, much like sound, travels and bends according to universal mathematical laws.
Okay, so instead of just viewing music as an art form, he is seeing the underlying code of reality.
Yes, beautifully put.
And he suddenly realizes that the ultimate symphony isn't happening in a concert hall in Bath. It is happening above his head in the night sky.
And he wanted to see that code in action. But to do that, he needed to look further into the dark than any of the standard equipment allowed.
Which brings us to a major roadblock.
Yeah, a big one.
The sources mention he tried using the standard refracting telescopes of the day, but they suffered from something called chromatic aberration.
Right.
You are going to have to translate that for me. What is actually happening inside the telescope to ruin the image?
Okay, so a refracting telescope uses glass lenses to gather and focus light. But glass has a quirky physical property.
Like what?
Well, when starlight passes through a lens, the glass bends the different colors of that light at slightly different angles.
Oh, okay.
Yeah, so blue light bends differently than red light. And because they don't bend uniformly, they don't converge at a single crisp focal point in your eye.
Leaving you with this blurry image surrounded by weird color halos.
Exactly, which is totally useless if you're trying to measure the exact pinpoint position of a distant star.
That makes sense.
So to fix this, you have to use a reflecting telescope. That was a design pioneered by Isaac Newton. Instead of a glass lens, a reflector uses a curved mirror.
Okay.
And mirrors bounce all colors of light at the exact same angle. It completely eliminates that blurry color distortion.
But wait, if reflectors solve the problem, why couldn't he just, I don't know, go out and buy a massive curved mirror?
Because literally nobody was making them big enough.
Really?
Yeah, making a good curved mirror in the 1700s was an absolute nightmare. They didn't use glass coated in silver like we do today.
What did they use?
They used something called speculum-metal. It's this highly temperamental alloy of copper and tin.
Okay.
It tarnishes easily, it is incredibly heavy, and it is brutally brittle. And Herschel wanted to see deep space, which meant he needed a massive mirror to catch as much faint light as possible. Since he couldn't buy one, he just decided to build a foundry in his own house and cast the metal himself.
That is insane. The details of this process in the sources are just staggering. They say he would spend up to 16 hours a day grinding and polishing these metal discs by hand.
Hand polishing metal for 16 hours.
Yeah. Why did it take 16 hours of continuous work? Could he not just, take a break and eat dinner?
No. If he stopped, the mirror was ruined.
Wait, really? Why?
Because speculum metal expands and contracts with temperature changes. When you are grinding a piece of metal, the friction creates heat. Right. If you polish too fast, the metal heats up and expands, which distorts the parabolic curve you were trying to shape.
Yeah.
And if you stop polishing to take a break, the metal cools unevenly and the surface warps.
Oh my God.
So he had to use slow, continuous, agonizingly precise rhythmic strokes. And the only way to test if the curve was right was to put the heavy metal disc into the telescope tube, wait for nightfall, look at a star.
And if it was off?
If the focus was even a fraction of a millimeter off, he had to take it back out and start the grueling process all over again.
The physical danger involved here is terrifying. There is this specific anecdote recorded by his sister, Caroline.
Oh yeah, the 30-foot mirror casting.
Yes. They are trying to cast a massive mirror for a 30-foot focal-length telescope. They have a furnace melting this copper tin alloy right inside their house.
Which is already a terrible idea.
Exactly. And suddenly the mold cracks. Caroline writes that the molten metal began to leak and everyone had to run for their lives out of opposite doors.
Just absolute chaos.
The stone flooring of the room literally exploded from the heat, sending debris flying all the way up to the ceiling. And William collapses onto a heap of brickbats, just completely physically destroyed from the heat and the exertion.
It really pulls back the curtain on early science, doesn't it?
Oh.
He wasn't sitting in some sterile laboratory doing math on a chalkboard.
No.
He was risking his life in a homemade basement foundry because he was utterly consumed by the need to see further into the universe.
Well, that 16-hour-a-day obsession does eventually pay off. He finishes a highly effective homemade Newtonian telescope.
He does.
He designs it to be viewed directly to maximize the light hitting his eye, and he starts systematically sweeping the night sky.
Just mapping everything.
Right. And then we hit the night of March 13th, 1781. He is out in the garden of his house in Bath, mapping the sky, and he notices an object that appears as a little disc instead of a pinprick.
A very crucial detail.
Yeah, and at first, he assumes it is a comet.
Which is, frankly, the only logical assumption at the time. But when he reports the coordinates of this fuzzy disk to other astronomers, things start to get strange. A Finnish-Swedish astronomer named Anders Lexell takes Herschel's observations and computes the object's orbit.
And what does that calculation reveal?
Lexell realizes this object doesn't have the plunging elliptical path of a comet. It is moving in a massive, nearly circular orbit, way, way out past Saturn.
The realization of what that means must have been world-shattering.
Oh, absolutely.
I mean, since the dawn of human civilization, the solar system had a fixed, unquestioned number of planets. Mercury, Venus, Earth, Mars, Jupiter, and Saturn. That was the entire cosmic neighborhood.
That was it.
In a single night, a self-taught musician in his backyard discovers Uranus, completely doubling the known size of the solar system.
And overnight, he becomes one of the most famous men in the world.
I bet.
He is awarded the Copley Medal, elected a Fellow of the Royal Society, and King George III appoints him the King's Astronomer.
Wow.
And that appointment came with a royal pardon, finally clearing him of the desertion charges from his military days back in Hanover.
Oh, there's a great bit of historical politics in the notes regarding what to actually name this new world, too.
Oh, the naming drama is amazing.
Yeah, Herschel tries to name it the Georgian Star, Georgium Cetus, to flatter King George, who, just pardoned him and gave him a salary.
A smart career move, honestly.
Yeah, but nobody outside of Britain wanted a planet named after an English king.
Definitely not the French.
No. The French actually called it Herschel for a while, just to avoid saying George, until the scientific community eventually settled on Uranus, keeping with the mythological theme of the other planets.
Right. And while that discovery secured his legacy, we really have to be careful not to fall into the myth of the lone genius here.
Absolutely.
Science is rarely a solitary endeavor. The story of Uranus and the mountain of discoveries that followed hinges entirely on the person sitting at a desk in the dark next to him.
His younger sister, Caroline Herschel.
Yes.
Caroline's story is incredible. William originally brought her over from Hanover to Bath to be a singer in his choir. But as his focus shifted to the stars, she basically became his indispensable partner.
She was the absolute backbone of the operation. You see, as William upgraded to larger telescopes, their workflow became incredibly intense.
Oh, so?
Well, if you are looking at faint objects in deep space, your eyes undergo dark adaptation. Your pupils dilate fully to let in maximum light.
Okay.
If William took his eye off the telescope to write down a coordinate by the light of a lantern, he would lose that night vision. It would take 20 to 30 minutes in the dark for his eyes to readjust.
Oh, wow. So he just couldn't look away.
He couldn't afford to break his gaze. Not for a second.
So Caroline essentially becomes a human data processor.
Yes.
But she is not just taking dictation. The sources say she is sitting at a desk near an open window in the dead of winter, freezing cold.
Interesting.
William is up on the telescope scaffolding, shouting down coordinates and descriptions. Caroline has this small artificial light so she can see her notebook, and she is writing everything down, calculating the math on the fly, and cross-referencing his shouts with existing star catalogs to see if what he's looking at is actually new.
It's unbelievable. And we must highlight her independent achievements, too. William built her a small telescope to sweep the sky horizontally, and she used it to discover 8 comets and 14 nebulae.
8 comets.
Yeah. She even rediscovered Comet Inc. She updated John Flamsteed's major star catalog, adding over 500 stars that had been missed.
That is just phenomenal.
It gets better. King George recognized her brilliance and actually granted her a £50 annual salary.
Which was a big deal.
A huge deal. That made Caroline the first woman in England to be honored with a government position and the first woman ever to be paid a salary specifically as an astronomer.
It's an amazing milestone, but the historical sources also reveal that this partnership had deep human friction.
Yeah, it wasn't all perfect harmony.
Right. These weren't just names in a textbook. They had very complex family dynamics. In 1788, William marries a widow named Mary Pitt.
Right.
Up until this point, Caroline essentially managed William's household and his life. With Mary's arrival, Caroline lost her status in the home. The sources note she was deeply bitter and jealous. Extremely jealous.
To the point where she actually destroyed 10 years of her own journals from this period out of sheer resentment.
Yeah, she just burned them. It is a painful reminder of the personal sacrifices involved in this kind of obsessive work. Caroline eventually moved into separate lodgings. She did continue to work as William's assistant, and they reconciled later in life, thankfully.
Right.
And after William passed away, Caroline actually went on to organize their 2,500 nebulae into zones.
Wow.
Yeah, laying the absolute foundation for modern deep space catalogs. And she eventually won the gold medal of the Royal Astronomical Society.
So well deserved. Now let's look at what happens when William scales up his ambitions. He has royal backing, he has a steady salary, and his sister organizing the data.
Yep.
So he decides to push 18th century technology to its absolute breaking point. He asks King George for £4,000 to build a Leviathan, the 40-foot telescope.
A monster of a machine.
This thing had an iron tube big enough for a person to literally walk through and a primary mirror made of speculum-metal that weighed 1,000 pounds. It's just massive.
It required a massive rotating wooden platform and an entire team of assistants just to move it.
It was the largest scientific instrument in the world, and it actually remained so for 50 years. He used it to discover two new moons of Saturn Mimas and Enceladus, almost immediately in 1789.
Okay, but I am looking at the schematics in our sources, and I have to push back on this machine a little bit.
Oh,
Yeah, it became this massive tourist attraction, inspiring poets like William Blake, but the notes also say it was an absolute nightmare to actually operate, and William preferred using his smaller 20-foot telescope for almost all of his serious work.
that is true.
So did he just build a giant royal vanity project?
Well, it is easy to view it that way because it was highly impractical. But it wasn't vanity. He was just hitting the ceiling of physical materials.
What do you mean?
Think about a 1,000-pound disc of metal supported only at its edges inside a tube.
Oh,
When you tilt that telescope up toward the sky, gravity pulls on that heavy metal. The mirror literally sags and deforms under its own weight.
oh, ruining the optical curve.
Exactly. Ruining that perfect curve he spent hundreds of hours polishing. The 40-foot telescope was kind of a necessary failure. It proved that if humanity wanted to see deeper into the universe, we couldn't just build bigger speculum mirrors.
We needed something else.
Right. We needed entirely new materials and precision engineering, which wouldn't arrive until the Victorians perfected silvered glass decades later.
So if the massive telescope was too cumbersome, what was he doing with his smaller ones?
Lots of things, but especially double stars.
Right. The sources highlight his work on double stars, but my understanding is that early astronomers thought those were just optical illusions. Like just two stars lining up from our perspective on Earth, with one actually being millions of light years behind the other.
Yeah, that was the prevailing assumption at the time. But Herschel did something unprecedented. He didn't just look at them once. He meticulously measured the angles and distances between these pairs of stars for 25 years.
Wow, 25 years of data.
Exactly. And over those decades of observation, he realized they weren't optical illusions. They were physically interacting. They were orbiting a common center of mass. He called them binary sidereal systems.
That is a staggering conceptual leap. He is providing the very first observational proof that Isaac Newton's laws of mutual gravitational attraction aren't just local to our solar system.
Yes. Gravity is universal. It works out there in deep space, holding distant suns together.
Amazing.
He was entirely rewriting the architecture of the cosmos. He also attempted to map the shape of the Milky Way galaxy by counting the density of stars in different directions, correctly deducing that the galaxy was shaped like a flat disk. And he coined a term we use every day. In 1802, he was looking at newly discovered objects that didn't show a planetary disk in his telescope. They just looked like tiny stars.
Oh.
So he combined the Greek words for star and shape and gave us the word asteroid.
I had no idea he coined that. And his ability to rethink reality leads us to an experiment in the year 1800 that completely altered physics. And he did it right on a table in his room.
Oh, this is one of my favorite stories.
Yeah.
It is a masterclass in the scientific method. He is observing the sun through his telescope. And to protect his eyes, he uses different colored glass filters to cut down the glare.
Right.
But he notices something strange. The different colored filters seem to generate different amounts of physical heat on his eye.
So the curious musician decides to test this.
Of course he does.
He passes sunlight through a glass prism, splitting the light into a rainbow on a table. Then he places thermometers in the different colors of the spectrum to measure the physical heat.
Right, and he watches the temperature increase as he moves the thermometer from the violet end of the rainbow through the green and yellow, all the way to the red. Red is the hottest visible light. But here is the stroke of absolute genius. To ensure the ambient room temperature wasn't just fluctuating and throwing off his data, he places a control thermometer just off to the side, past the red end of the spectrum, where there is no visible light falling at all.
Just dark, empty table.
Yes, just to control.
And the thermometer in the dark space recorded a temperature 1 degree higher than the red light.
His eyes told him there was nothing there. The space was blank. But the thermometer proved energy was hitting the table.
That is chilling.
He concluded that there must be an invisible form of light, a ray that transmits heat but cannot be perceived by human vision.
And he had discovered infrared radiation.
He proved that our eyes are only decoding a tiny fraction of the reality that surrounds us.
That single experiment on a tabletop opened up the entire electromagnetic spectrum. X-rays, microwaves, radio waves, ultraviolet. The profound realization that the universe is screaming with invisible information started right there.
It really did.
Now, a mind that expansive, constantly pushing into the unknown, is bound to swing and miss occasionally.
Oh, for sure.
The notes show a few theories where his logic led him to some pretty wild conclusions. He theorized that there was life on the moon, arguing that the craters look like the English countryside.
Which is funny.
He believed Mars was populated. He even speculated that the interior of the sun was a solid, cool surface populated by beings adapted to the environment,
Oh boy.
and that the glowing part was just a luminous atmosphere.
Yeah, solar aliens are definitely a stretch. It just shows the raw, unpolished nature of the scientific process back then. But there is another theory he had that got him fiercely ridiculed by his contemporaries, which actually proved to be incredibly visionary once you look at the mechanics of it.
Right, this is the wheat theory. So
Yes.
he tracks sunspots for 40 years. He notices periods where there are very few sunspots, a period we now call the Dalton minimum.
Right.
He then decides to pull up historical records of the price of wheat from Adam Smith's book, The Wealth of Nations. And he claims there is a correlation. Fewer sunspots equaled higher wheat prices.
And his peers just laughed at him.
I mean, I would too. Why connect giant spots on the sun to the cost of bread in a London market?
Because he wasn't trying to predict the economy. He was trying to track solar energy output.
Oh.
Yeah, he hypothesized that fewer sunspots meant the sun was emitting less energy. Less energy reaching Earth means a colder, wetter regional climate. A colder climate leads to terrible agricultural harvests.
And bad harvests drive up the price of wheat.
Exactly. Modern scientists still debate the statistical significance of his specific historical data, but the underlying mechanism he proposed was brilliant.
It makes total sense.
He basically initiated the study of paleoclimatology and solar cycles, linking the behavior of our star directly to Earth's climate. He wasn't crazy. He was just 2 centuries ahead of his time.
Yeah, he really was. When you step back and look at this entire journey, it changes how you view the night sky.
It really does.
Why does this 18th century oboe player matter to you today? Well, next time you scroll past a stunning deep space photo from NASA, a spiral galaxy, or a glowing nebula, look at the caption.
Yeah, look closely at it.
You will almost always see an NGC number, like NGC 26A3. That stands for the New General Catalog. That is the very list that William and Caroline started, sitting in the freezing cold, shouting coordinates through an open window.
And when we launch our most advanced space observatories today, trying to peer into the deepest, oldest parts of the universe, we don't rely on visible light.
No, we don't.
We use infrared telescopes, like the James Webb Space Telescope, or the European Space Agency's observatory, which was quite fittingly named the Herschel Space Observatory.
We are quite literally seeing the universe through William Herschel's obsession, a musician who ground metal mirrors by hand until he collapsed, just so he could see the ultimate symphony.
It is a beautiful way to think about it, and I want to leave you with one final thought to mull over today.
Okay.
Think back to that incredible moment of discovery with the prism. Herschel placed a thermometer in the dark, empty space, where his human senses told him absolutely nothing existed. He measured the blank space, and he found an entirely new spectrum of reality. Makes you wonder, what invisible things are sitting right in front of you in your own life right now, just waiting for someone to measure the dark space differently?